Hello dear students, welcome to my channel Mastering Physics and Math. I use this channel to serve you wherever you are. So please do not forget to like and share in order for every one of you to benefit. In this paper 1 multiple choice, Cambridge International AS and A Level, Physics, May-June 2019. Question 11. A helium atom of mass m collides normally with a wall. The atom arrives at the wall with a speed v and then rebounds along its original path. Assume that the collision is perfectly elastic. What is the change in the momentum of the atom during its collision? Since the collision is perfectly elastic, so the impact velocity equals the initial velocity in magnitude but in the reverse direction. So this is the velocity before impact. After impact, the velocity is negative v. So initial momentum equals mv. The final momentum after impact is negative mv. So the change in the momentum is the difference, which is equal to mv. A cylindrical iceberg of height h floats in sea water. The top of the iceberg is at height small h above the surface of water. The density of ice is rho I and the density of seawater is rho W. What is the height h of the iceberg above the sea water? Now, according to Archimedes' principle, the floating force equals the weight of the displaced water. The weight of the displaced water equals this volume multiplied by the density of water multiplied by g. So floating power floating force suppose the base area is A, so the volume is A times H capital minus H small times the density of water times G. This force equals the weight of the iceberg equals its volume. Its volume is the base area times the H, capital H, and times the density of ice times G. Now Ag is a common factor, so dividing both sides by Ag and expand here, we get rho W capital H minus rho W small h equals rho I capital H. Now rearranging this equation, Now taking this term to the right side, changing its sign, equals rho water times H. Now H equals dividing up and down by rho W, so we get this answer. A couple is applied to a tab as shown. What is the torque of the couple? The torque of a couple is defined as the product of one force times the normal distance between the two parallel forces, which is 2D. D plus D, 2D. 2FD. A crane uses a counterweight to stop it from toppling over when lifting a load, as shown. The counterweight has a mass of 5,000 kilograms. The crane is required to lift a load of 12.0 kilonewton, and the horizontal distance from the pivot to the load is 17.0 meter. How far from the pivot should the center of gravity of the counterweight be positioned in order to keep the crane in equilibrium? To keep the crane in equilibrium, the net torque must equal to 0. So the clockwise torque of this force, T negative, equals the positive torque of the counterweight. And let this distance is x. The weight of the counterweight equals its mass times g, equals 5,000 times 9.1. Now the net torque, sigma 2, must equal to 0. So 2 positive equals 2 negative. The torque equals the force times the normal distance, we assume it x, times sine 90. The angle here is 90. Sine 90 degree. This equals the clockwise torque, which is equal 12 kilonewton, 12,000 newton, times the distance 17, times sine 90. Now sine 90 is 1, and dividing both sides by 1000, we get here 5 times 9.81. X equals 12 times 17. Using the calculator, 12 times 17 divided by 5 times 9.81. The answer is 4.159, but we take the answer to three significant figures. 4.16. It is rounded to 4.16. So this is the qualified answer. Three parallel forces act on an object. As a result of these forces, the object is in equilibrium. What must be correct for these forces? A. They all act along the same line. B. They all have the same magnitude. C. They do not all act along the same line. D. They do not all have the same magnitude. The conditions for equilibrium, we have two conditions here. First condition is that the resultant force equal 0. And the second condition is the net torque about any point equals to 0. So sigma torque around any point must equal to 0. And this is the qualified answer. In this case, these two conditions are fulfilled. Thank you for following me, and bye-bye.